Well, I think we can pretty much get ready to start. So, my name is Roman Gomez, and I am very happy to say I'm a San Antonio native, and I have been coming to San Japan now, God, I think it's something like 7 years. And I believe out of those 7 years, I have presented my Physics of Anime panel 4 times, and this makes it the 5th. So I'm really, really happy that they allowed me to come back. But all of those other times, I did it by myself, and which to everyone's chagrin because I'm a terrible presenter. But I finally get a chance to present with one of my very, very good friends, Dr. Justina Sokol. We're both from Southwest Research Institute, and we will go a little bit more into what we do, if this thing will work for me. So, again, you're in the Physics of Anime redo. Again, I'm Roman Gomez. My colleague is Dr. Justina Sokol. And we are going to talk to you about strange things, because that's what the whole point is. So our panel outline, we allowed you to scan our QR code. Thank you very much for doing so. And we figure we'll talk your ears off for about 40 minutes or so. We do want to leave some time for questions. That's the whole point. This is not supposed to be some kind of sermon or anything like that where you're supposed to just agree with everything I say. My wife would tell you, please don't. And again, the whole point is to get this going back and forth. This is something that it's an ongoing passion of mine, is physics outreach and education using anime. And it's such a popular medium, so we might as well use it. And we might as well use it to discuss science. So, who are we? Well, yes.
Did you say about the QR code? Did every one of you scan the QR code and fill in the survey? Okay, thank you for doing this, because Roman is doing a research.
I am actually doing research. I will write a paper based on what we have in there. So you're helping me get published. I need to publish or perish, right?
What you notice, there's a change to this panel, and I'm very thankful to Roman for allowing me to doing this panel together with him. I hope you will enjoy. And you didn't mention our special topic this year, which is...
Wait.
You forgot?
Yes.
It's space weather physics.
Oh, that's right. And I've been working this all the time. That's probably what it is. So, yes, and we work on space weather. I have worked at Southwest Research, and you're like, space weather? No, it doesn't exactly work out, does it? Space weather. I mean, it's the kind of climate that surrounds us, and it's pretty much dominated by the sun. Now, we are not made to actually measure things by ourselves, right? We're not made to register particle impacts or anything like that. We'll talk about what ends up happening if we do. But so we have to make instrumentation to do so. And that is exactly what we do at Southwest Research.
And we do, you have a proof here.
Yeah, here's the proof. We're actually in the lab with my anime manga cosplaying cowboy shirt on, because that's how experimental physicists dress.
And the space weather instrument.
Yes, this is Tracer. So we'll show you some very nice vanity photos in a little bit. And again, just to prove that I'm doing research, this is me at the American Geophysical Union meeting, presenting a poster dressed in cosplay. It was very strange. The only thing I was missing, I wanted a plush Pokeball, so when people came by, I could throw it at them and say, I choose you. I just missed out. I'll get that next time.
I feel the perfect cosplay to be safe here from Dr. Stone.
Actually, yeah. We might talk about it later. Okay, and again, obviously proof that I've been doing this for a while. This was Dr. Sokol back in the day. This is after I coerced her into actually doing this panel with me. Okay, so when we're at Southwest Research, like I said, got to wear the colors, here. I've been working there for 18 years. We launched the Tracer's ACI mission, actually Tracer's mission on July the 23rd. I now have a full 6-pack in space now. We launched 4 instruments back in 2015. We just launched 2 more. And we've got another one coming up in September. We'll show you a pretty picture of that. Now, that would be SWIFO L1 SWIFs. That's going to be what's known as Lagrange point 1. And Dr. Sokol is working on IMAP, the interstellar.
Interstellar mapping and acceleration probe. They both sweep on and with sweeps, and IMAP, which takes with 10 instruments, all of them designed to together study how our sun interacts with the galaxy around us. So both of them September 21st September.
Yep.
So watch for this.
Yeah, and again, this is a beautiful campus where we normally work, except that we know that that's false color because it's August and in Texas. So
Everything's brown.
there, color may be false, just like these are the Tracers ACI instruments that launched. Again, they are made to look at space plasmas. Plasma is actually the most abundant form of matter in the entire universe, normal matter. We don't see it, we don't experience it because we simply don't live in the temperatures at which it did. And if we did, we'd be in a world of hurt. So let's be happy that it's around. Then this SWIFO, this is the space weather follow-on at Lagrange point 1, and SWIP stands for the solar wind plasma sensor. This thing is meant to just stare at the sun, kind of like what we did when we were kids and we were dumb, right? So yes, it's supposed to just stare at the sun and tell us when this is actually our last line of defense against solar extreme events, where we can actually detect these very high mass, high flow, high rate plasma events, solar flares, coronal mass ejections, things that actually can cause some severe problems. So this will launch along with IMAP, and it will also be up there. I think its primary mission is 5 years. So, those are the optics I got to play. Dr. Summers?
And this is my contribution to IMAP. I told you there are 10 instruments, but I contribute to one, IMAP low, which is designed to study very low energy particles, those that are very cold coming from the interstellar medium up to us. And how do we measure them? We measure them for a special technique, and it's called conversion surfaces. And on this picture, you have our technicians and Sviri working on assembling the real flight model of conversion surfaces on one of the mounts. And me is there the small reflection in the back. It's me watching them, whether they do the work the right way.
Okay. Now, that's not why you came here, okay? Yes, we love our hardware, but that's not why you came here. This is called the physics of anime, right? So what are we doing? Well, here's the question. And I know we've all watched some anime and said, is that even physically possible? And in most cases it's not. But even when it's not possible, it still gives you a chance to talk about physics. And so the idea is, if we see some event that occurs in some anime, we ask, okay, is it possible, or are they at least representing those physical properties or those physical principles correctly? Can I kind of draw that out and we can have a conversation about it? There will be certain times when we're like, well, if I allow some miracle to occur, like some massive object being able to travel at the speed of light, then the question is, are Einstein's special principles, right, the special theory of relativity, is that accurately represented? And in that case, again, now we can kind of tease out the physics and talk about it in a really friendly way, because nobody likes scientists who throws equations around, right? Those people are horrible. Just ask my students. Okay, so,
Yes, and the power of anime already appeared in one of the cartoons. Do you watch Spy and Family? Yes. So you probably remember this episode, and you know that Anya loves cartoons, Bondman, right? And Anya struggles at school because she struggles with fractions, with math. And in one of those episodes, when Anya is very occupied with watching Bondman, then she realized that there is a problem with the bullets inside the pistol, right? So she asked Lloyd, how many bullets can Bondman pistol hold? And he replies, 8. So then she replies to him, he has 2/8 of his ammunition left. So she learns math. She uses math to learn about her hero. And here's Lloyd's face impression. She will learn faster if we use her cartoons as replica. The power of anime.
there you go. You learn fractions. There you go. Now, again, is it a stretch to think? Again, is it a stretch to think that there are anime that don't accurately represent physics. Dr. Stone is really good. Dr. Stone is excellent. Cells at work, again, I will stand by my conclusion that cells at work would be an excellent way to teach grade school students about biology. The only problem are those doggone white blood cells and how violent they are. So, you know. But thankfully they are violent because they keep us alive. Or on the movements of the earth. So I teach astronomy at a local community college. And I guess what you can say, the procedural path that they take going from the geocentric to the heliocentric model is accurately represented. I mean, and they're still using some of the old names, right? They still focus on the fact that the Greeks were focusing on tendencies and things like that. They really hadn't started looking at physical laws yet. And again, Pothbury Diaries.
Solving mysteries for scientific thinking. I really love how Mao is solving mysteries and puzzles through the correct way of scientific thinking. It is illustrated perfectly in this animal. Understanding basic physics, basic chemistry, basic biology. These are the principles very nicely shown in the Pothbury Diaries.
I mean, she's an about carriage makes her physicist. So it makes sense.
Yep. And here you go.
And my turn. So done. Can I take the question?
Of course, let me get out of the way.
So we are starting with done. I really like season 2 when there is a lot of physics, especially in episode 3. It's really packed with physics, the basic physics. So first of all, we start that Gigi, Momo, Okarun, and Turbo Granny are trapped in Earthworm's den. So they see that the Earthworm can localize them but cannot see them. So Gigi notices that the Earthworm reacts to the sun. It's reacting to the sun. And what's that? This echolocation. The same one that animals like bats use to localize their prey or the obstacles on the way when they fly. So basically the same principles. So the other thing that caught my attention is that Gigi realizes that Momo and Okarun, something is happening to them, and he doesn't know what. And here Turbo Granny comes. I love Turbo Granny. And she says, these are psychic waves. So the waves that affect Momo and Okarun for some reasons, but not the others. And here brings us to the range of the wavelengths and how we can hear the wavelengths. There's a specific wavelength range that we humans can notice, can hear, but there are also the wavelengths that we cannot hear, but the other animals can, like dogs, the dog whistler, right? The dog can hear it, but we don't. So the same principle, very nicely way illustrated in Dandada. But this is not all. Whoops.
Oh.
Right?
There we go.
Here, the culminating point of this episode, but not the best one. Another one. They are trapped. Eggworm is attacking them with their waves, and then Evil Eye comes, and it stands between our friends and the Earthworm, protecting them. Well, how it's protecting them? They don't know what's going on, and then Turbo Granny, I love this moment in this anime. When she says the Evil Eye's curse and the Earthworm typing waves are cancelling each other out. Basic physics. This is basic principle of adding and suppressing waves. So if you have a wave and you have two identical waves and you try to add them, what's happening? They are reinforcing. So if you have another me talking here in the same pace, you will hear me louder, right? But if you have me talking like in opposite, generating all waves in antiphase, this is how we call it, but there is like opposite how illustrated here, they will cancel each other out, which means you won't hear anything from me. So this is very nicely illustrated and talked about here, this canceling of two waves interacting with each other. But this is not all. This moment, rocket science in episode 3, dun dun dun. By the way, I met Okarun this morning. That was great. So in this episode, they are trying to escape from the Earthworm den. And how they're going to do? And Okarun is the one who helps them. He's the one who pays attention in classes, of course. And he said that you launch he launched Momo straight up like a multi-stage rocket. So let's look at this picture here. We have an opera room with his turbos running power who is giving Momo a turbo booster kick. Right here on this armchair, she's going up, but she's losing the energy. And what she needs to do then she uses the second stage of her psychic power, making a spiritual lift up to the hole up here to free herself and help the others. So I really like this analogy to the multi-stage rocket, the same rocket that launched tracers a month ago.
There was much rejoicing.
So this was a screenshot from Trace's launch from Vandenberg, and we see that they use Falcon 9 rocket, which is two-stage rocket, which means there are two rockets stuck together. And they all work together to overcome the limitation of the velocity change by splitting the change of velocity in time. So the same thing what happened to Momo. And she was hit by Ocaron. At the same point, she lost her energy, the kinetic energy, and she had to use her power to lift herself up. So the same analogy, very beautifully pictured, and in analogy with Tracy's lunch, right? There's another anime that streamed spring this year, and it's called The Apocalypse Hotel. Did you watch it?
Yes.
Oh, you don't? Thank you. If you didn't, you don't know what you missed, especially episode 7, which is...
Trust her, she's a doctor, she knows what she's talking about.
It's really packed with physics. It's 8 minutes of physics, space physics. So our main characters here, Honko, which graduated the space engineering program at Honko University, which, oops, problems with that. Honko is a shapeshifter. They arrive at Earth to find a rescue. And we have Yachiyo. Yachiyo is a robot. She stays at Earth waiting for humans to return to her. And they both, in this episode, trying to launch a rocket to space. They are launching 2 payloads. One rocket to advertise their hotel to the extraterrestrial lives to come to the hotel and visit Earth. And the other one is about launching a weapon to protect themselves, the hotel, from the threats from outside. They're building a rocket, and Honko is the one who builds the rocket, saying, I will send you into outer space with my rocket. And it took her 70 years to build the rocket. Oops, this is one dimension. So here we have the concept of the weapons, rods of gold, made from a tungsten. I really like this episode because we use tungsten in our instruments for scientific reasons. And the principle of operation is that you will drop something from far away and this will damage the threat on the Earth. But this is not the topic of this. We see they both work together hand in hand using lots of their knowledge, robot knowledge, AI knowledge, and also Honko graduate from the university. There is a lot of technical terminology in this episode, very short, 8 minutes, by very packed with terminology. And at the end, Yachiyo is going to space. And wait for that. Yachiyo is in space, right? She launched the advertising payload, now she's launching the other payload. Everything goes according to schedule. Here's Yachiyo. But then, suddenly, it is, oops. Something happens. And Yachiyo is in a situation like, Houston, we have a problem. And shortly after that, receiving lots of error communication, Yachiyo receives recommendation to conversion into space debris. And the mission is terminated. So what happened? So let's go to the Mission Operations Center at Earth when we have a Honko, the main engineer working on the mission, and she realizes, oh, a solar flare. So what is a solar flare? Roman will talk about this shortly in more detail, but this is a threat to humans and to electronics in the outer space. At Earth, we are protected by the Earth's magnetic field, so we are safe. But whenever we launch anything outside Earth, we need to deal with extreme radiation. And as correctly noticed in this anime, this is a large amount of high-energy particles, so they can damage electronics and anything what is there. So we need to take proper measures to protect them. And what is not very correct in this episode is that the solar flare damaged Yachiyo almost immediately, which is not correct because those solar flares can take from about 1 to 7 days to travel to Earth. So they would be able to rescue Yachiyo, but they didn't. And Hong Kong noticed that, oh, that's good, Yachiyo is a robot, but Yachiyo is not space qualified robot. She hasn't been built at Sweden.
We didn't build it. That's what it is. So that leads me to talking about I thought it was a really great anime. It's funny, one of my bosses, so when I went to Anime Expo, my boss said, well, we're sending you there, Roman, so you need to talk about space physics. I go, I have exactly the anime to talk about. So I'm going to talk to you about planets. Now, has anyone seen Planets? No? I highly recommend it, besides it was written by the same person who did Vinland Saga, so it's got to be good, right? But this is set in 2075, which is really not very far away, but it's tackling a lot, or addresses a lot of the issues that we currently have as a culture who wants to become a spacefaring culture. So we're going to talk about the consistent human presence on in Earth orbit and on the lunar surface. We're going to talk about space debris, the need to forecast space weather. Once you've seen it, Houston already kind of talked about it. We'll go a little bit more in depth. And then the effects of space on human biology. So again, tackling the effects of space on human biology. So who's married or in a relationship where you sleep next to someone? Show of hands. Good, you're getting radiation every day. That's good to know, right? If you like bananas, congratulations, you're consuming radiation. Brazil nuts, oh, white chocolate, macadamia nuts, oh, so good. Yeah, congratulations, Ray. You're getting radiation. Potatoes too, yeah, if you like your mashed potatoes. Now, again, we live a very kind of graced existence here on the surface of the Earth. We've got an atmosphere that blocks things like gamma rays and X-rays. But we also have a magnetic field which shields us from any kind of charged particles. But what happens when you get outside? Well, all of a sudden you're going to be inundated with all of these things that you were originally protected by. And, when I'm teaching about radiation in my astronomy class, I talk about when you go and you get your teeth X-rayed, right? It's a real short burst. If you're a Russian firefighter in Chernobyl, probably not going to be so good at that point, right? You're getting a huge, massive load, and that's almost what's happening. And an example of that occurs in the anime is Giggle Gangaresh. This is one of the main characters, Hachimaki's mentor. He's been in space doing operations for 20 years. We've never had anyone operate in space for that long, and now in this anime, you've got a situation where people are serving entire careers out in space, and you're essentially unprotected. So the question is that they're putting forward, and again, I think it's really important that they paid attention to that, is that what are the results of the extended exposure? And from what we understand here on the surface of the Earth, it would be very similar out in space. Another thing that they paid attention to is you've got a reduced gravitational field on the surface of the moon, right? 1/60 the gravity. What happens if you have someone who's born on the moon and develops there as well? And so one of those things in this, our biological systems are optimized for growing up on the Earth. What happens if you are growing up on the moon? Well, there's a character by the name of Nono. She's a 12-year-old girl, and she's already taller than the main character, 6 feet. Right? I mean, if you take a degree in biology and take embryology, you'll find out that everything grows on what's known as a gradient, how these things flow. And gravity pretty much directs how far these things will flow and and build up their structures. But if you're in a lower gravity environment, what ends up happening? This is a possibility. Space weather. Really, really important. I know it sounds silly, but it's really important. So when I was young and stupid, now I'm just stupid, I was a United States Army infantryman, and we were doing a combined forces exercise. Actually, we got to play the bad guys. We were op 4. So we got to play all the dirty tricks on the 82nd Airborne Division, 7th Infantry Division, 101st. Well, we were supposed to ambushed some elements from the 7th Infantry Division and they never showed up. So what do? Well, we flop on our rucksacks, read books, but eventually, the sun goes down. Well, it just so happened that this was in 1989 and a large X-class solar flare had erupted from the sun about a week prior. Not only that, but 2 coronal mass ejections, which is like the sun hawking a giant plasma loogie at you. 2 of those things are flying out. So you have this solar flare hit and then these coronal mass ejections, and what ends up happening is you compress the magnetic field on the day side, and on the night side you have these nasty precipitations coming in. When you're in northern Florida, you saw really beautiful aurora. Okay, the first time I saw the aurora was in northern Florida, and it's sure enough, what I saw as aurora in Florida, Quebec had their entire power grid knocked out. Oh. Yeah, because what ends up happening is this charge coming to the ground looks for anything that's conductive, like a power grid, and then just spreads itself all over the place. So now if we want to see the aurora, we can hope for something like that, right? Here in San Antonio, nice power outage. We're going to be great. And that's exactly the kind of stuff that the solar wind plasma sensor that we showed earlier, that's what this is supposed to be looking for. And, again, this constant human presence in space. So I could not find any kind of information on this thing, okay? This is the ISPV, the International Spaceport version. This would be their version of maybe the Artemis space station, something, Artemis is a start off of something like this. This is now an inhabited space station, and they spin it so that you can have gravity, right? You can't, something generally will have gravity because it has mass, but what if you don't have a lot of mass? What do? You spin this thing up to get centripetal acceleration. That's actually something called a von Braun space station. And so this gravity, again, is generated by the spin, but what ends up happening is you experience gravity in these outer areas, and as you move further into the structure, you end up having 0G. So you could do 0G training in space without ever having to expose yourself to the environment. Again, I had to do a calculation here. It just goes to show you how much of a nerd I am, but I know I'm in good company, so this is good. But again, if it's 1 kilometer in radius, spinning once every minute gives you 1 G. So that's spinning once a minute, I don't know, that's pretty fast actually if you think about it. All right. Again, this constant presence on the moon, Mare Tranquillatus, they have a spaceport and a depot, a helium-3 mining colony, multiple outposts. They actually have highways on the moon. Again, these are all things that could be done. And as a matter of fact, if you've been paying attention to the news, right now they're talking about putting a nuclear reactor on the moon, right? Yeah, well, on the moon it's not so bad. Unless we want to be inhabited there. And again, that decreased gravity, we already talked about No-No and her growth. But there's another thing that kind of goes on in there, which I thought was hilarious. They have high-rise buildings in these enclosures, and they have these people who are space ninjas or lunar ninjas. Now, we could all be lunar ninjas, believe it or not, on the moon. We could run around, jump, again, 1/6 of the gravity. I'm totally looking forward to that, right? And again, they have this really tall skyscraper. They're trying to escape from a fire, and all of these space ninjas suddenly jump from like a 70-story building. You're like, well, this is certain death, but not in the lunar gravity. The only person who gets injured is Hachimaki, because he doesn't know, he's never trained as a space ninja, but apparently everybody else did. So the other thing, and this is actually something that is really concerning us these days, right? Because part of becoming a spacefaring culture is actually keeping our skyways clean. And space debris is a growing problem. And it can continue to get worse if we're not cognizant or not taking the precautions. Like never making anything out of titanium again that needs to burn upon re-entry, because that stuff doesn't burn up, okay? It never does. Oh, I went one more. Didn't mean to do that. But here I am talking to you and knowing full well that I've just contributed to the space debris problem just 2 times over. As a matter of fact, those are the spacecraft that we launched back in 2015. That's okay. And there's 4 of them. So I'm sorry, my bad. They're still working though. They're not being decommissioned. Giving a wrap up. I mean, it's often rare to find an anime that will address certain issues that are, I think, very germane to our existence in this day and age, but this is one of them that is. And so I give it 4.5 stars. I highly recommend you watch it. If you haven't watched it, watch it. I'm a lot saver.
Another anime
There you go.
And especially, I mean, here the episode when there is a battle between Aura and Frieren. So if you watch Frieren, you know that Planet told Frieren to suppress her mana. And the reason for that is to deceive the demons, because demons judge others by the level of the mana or the size of the mana. And when Frieren does it, she seems very weak compared to Aura. But the moment that she frees her mana, she overwhelms Aura, and she won the battle. And whenever I see it, even right now, it reminds me something about its own star. So when you look at the sun, you can see it here, but imagine this is like foggy day in San Antonio. During a normal day, we see a whole ball of gas billion of miles away, right? However, during a special events like the total solar eclipse, from the Earth, we can see the power of the sun. So what you can see here is the sun covered with the moon, so that we can see the powerful solar corona. Isn't it beautiful? It is. And it reminds me the power of Frieren's mana. Because when you look closer, we can see lots of different things here, like coronal mass ejections. All the origins of the solar flares that can harm us here on Earth or our instrumentations out there. We can see a beautiful magnetic loops, the open magnetic field lines, prominences, and the solar wind. And can you imagine that this solar wind that is produced on the sun, those protons can travel far away from the sun, as far away as 100 astronomical units, and 1 astronomical unit is the distance between the sun and Earth. So this is very, very far away. And how far? It means that for a single particle, like a proton, of a speed of this much mass per hour, it takes 14 months to get to 100 astronomical units, so that far away. And what sun produces fars away that far and interacts with our galaxy, what's around us. And we, as a humanity, launched 2 spacecraft to go far away to the edges of our solar system, outside the influence of the solar wind on our sun. And one of them is Voyager, and it took 30 years of the Voyager to get to 100 astronomical units. The other spacecraft is New Horizons, and it's still on its way after 19 years. It's only at 63 astronomical units. And it'll take it a couple of years, maybe more, to get there.
Remember, Voyager was launched in 1977. So,
Yes.
yeah, that's how long it's been out there. Sorry. The start of this video.
Yes. So our sun is a beautiful star. It's a star of multiple places, as Frida, because Frida is a mentor. She's a student. She's a woman. She's an age. She's an elf. She has many faces, and our star as well. And we can look at different phases of our sun by the wavelengths. Again, wavelengths from the beginning of this panel. Different wavelengths give us a different picture of the sun. So what you see here on these images is our own star, sun, at the same day, the same picture, the same hour, but at different wavelengths. So we can see this one, which is the very closest with the sunspot numbers. Here, this is the region here. But when we look at a different wavelength, we can see that this is very hot region of the sun. That something is going up here, and probably a solar flare can be a threat from this region, and we need to watch this region. And so on with all the other wavelengths. Some of them are quite boring, like here, or this one. But yes, so it really depends on how you see things. Like for the demons, how they see Frieren. And we use a different wavelengths to learn different things about the sun. And sometimes they are outside our humans' perception, and we use for this different instrumentation, ground-based on Earth, or to space instrumentation to learn more about our own sun.
Oh, I forgot that I get to talk about Fire Force. I'm so excited. So, yeah, it was funny. So I absolutely adore Fire Force. One of my favorite anime here at the end. And you're like, well, is there physics in Fire Force? Actually, there is. Some of it is practiced well, and some of it is bad and very disappointing. So I was asking who in the 8th is paying attention in class. And this is the science of Fire Force. Now, again, while fighting the assassin, so I mean, it would be really bad if Victor Licht wasn't paying attention to science, since he is a science officer. But I thought it was really interesting when he's fighting gold. Interestingly enough, gold does not have any kind of magnetic properties whatsoever. But people who have done actual research and used what's known as a heat gradient, because remember, all the powers in Fire Force are based on heat, right? Heat generation, fire, things like that. So sure enough, if you can establish a heat gradient across a gold surface, in theory, you could generate magnetic fields because of the currents that come into play. You've got these kind of swelling currents. So that's what's going on here. Now, when counteracting gold, she was actually, I don't know if I think it was like 2 or 3 episodes where she was just whooping tail big time, right? And they're like, how do we beat her? Well, leave it to Licht. He knows, 1, iron is ferromagnetic. 2, Tamaki flame tails and their thermite together can, get iron to the point where it can melt. 2,300 degrees Fahrenheit. He actually says that in the anime. And the funny thing is, you would think, well, it's still iron, it's still magnetic. It turns out that Licht was smart enough to know that when it's above its Curie temperature, 1,400 degrees Fahrenheit, it will not succumb to any kind of magnetic field. So they sling this thing at her, the gauntlet is negated, and I'm not going to show the particular clip where they take gold out. It's just a little on the rough side, but Joker, surprisingly, was paying attention in science class. So he noticed that Shinra's a blue flamer, and that's a terrible play on words, but you know that or not. Still fighting Captain Burns. Captain Burns is a Gen Xer. I checked it up. He's 50 years old. We're kind of tough old birds, man, so I'm not surprised. But Joker notices, and I think it's in the anime, it's got like that, I think the weight of death kind of thing that like comes across on his forehead, and suddenly, I guess he's just really gotten serious, right? So all of a sudden, these typical orange flames suddenly start to go blue. And Joker's actually pointing out 2 very interesting scientific principles that are going on here. So one of them I teach in astronomy is something called Wien's displacement law. This is what we use to determine how hot what the peak temperature, or what the temperature of a star's photosphere is. And it's just the temperature is equal to some constant divided by some peak wavelength. But there's another thing that's going on. If you've ever played with a Bunsen burner in chemistry class, those are fun, right? Can't believe they let us play with fire when we were kids, right? But apparently they did. So, again, that if you have that thing down too far, you have a kind of like a weak burning flame, right? You've got a lot of incomplete combustion. And obviously what's going on here is, 1, Shinra's starting to burn hotter because he knows he's got to up his efforts. But apparently he's also consuming more oxygen, so he's burning things more efficiently. So Joker is definitely getting an A in my class. But somebody's going to flunk, and this guy right here just totally disappointed me, because I love Shinra. It's one of my favorites. I mean, other than Benimaru Shinban, this is my other favorite, right? So again, he's fighting Captain Burns and not doing so well. Again, I point out that Burns is a Gen Xer, so our entire lives were torture. But he says, well, I need to move faster to do more damage. And notice what he says, kinetic energy equals mass times acceleration. When I saw that, I got so incensed. I was like, what in the world is going on here? Shinra, you're killing me. Because we all know that force equals mass times acceleration. And probably why Burns is handing him his own butt on a platter is because he didn't pay attention in class. So very important to pay attention in class, especially when you're fighting somebody from the first. So, in conclusion, again, I always point this out. Should you be watching anime to learn physics? Probably not. Probably not. But I will tell you that it definitely saved my life back in my master's degree. Some of you maybe heard the story. I was writing my master's thesis on dark matter detection. And I had these wave functions floating around in my head that, that these particles that are supposed to exist, supersymmetric particles. And I talked to my friend Albert. I'm like, Albert, I've got to get this out of my mind somehow. So he gives me the entire Soul Society of Bleach on like 5 USB discs, or 5 USB drives. And I just hammered it through, and it's like, oh, demons out. Thank you so much. I mean, we all need to take a break from time to time. But, I mean, obviously, I think it's using it as a vehicle for education, for science outreach. The whole idea is, I don't want to come up here and talk to you with technical language. I'd rather let's have a conversation about something that we love. And I absolutely love anime. I've loved it since I was 8 years old, and I hope to have anime themes played at my funeral. That's so Amen. There you go. So, if you have any suggestions, please, I shanghaied this, thephysicsofAnime@gmail.com. That's mine, yes. Please feel free to stick around and ask questions. Please take our survey. It's just one question. And then we still got plenty of swag up here. So God, thank you so much. We appreciate it. We love you guys. Thank you very much.